Bye. So what was the last topic? You told real depth and apparent depth, right? So last class, I remember we started refraction of light. Let's just recollect and then proceed to the next part. So under refraction of light, we saw the definition of it. What was the definition? Bending of light when it travels from one medium to another, right? And why does this happen? The speed of the light will change from one medium to another. So basically, if anybody asks you what is refraction of light, you say bending of light due to the change in speed. Okay. When light moves from one medium to another, right? When light moves from one medium to another, what parameter does not change? Why? So this is an often asked question. Why does the frequency not change? Most of the time you'll get for 1 month. So I gave you the hint also. The answer to that lies in the previous chapter. Frequency is the characteristic of whom? Of the source which is producing. So frequency remains unchanged. Frequency remains unchanged because it is a characteristic of, yes. It is a characteristic of source which is producing it. Third point. There are different kinds of media that we discussed based on the speed of the light in that particular medium. What are they? You classify them as rarer and denser. So what happens in a rarer medium? Speed of light is more on a comparative basis, whereas in a denser medium, the speed of light is slightly less, right? So then we saw another concept called as refractive index. What is the refractive index? Ratio of speed of light in, that is the relative. Air or vacuum to medium or medium to air or vacuum? So is it air by medium or medium by air? Why?
Air by medium.
Because I gave you that formula. Other than I saw you looking at the notes and telling me. Confident I will. But what is the reason? You should question the logic, no? So speed of the light is maximum in which medium? I've seen people getting confused in exam. Suddenly they'll make mistake here and there. It's a waste of your energy. So if you remember, what is the maximum speed? So which medium has the maximum speed of light? Vacuum or air, which is 3 into 10 power 8, 3 into 10 power 8 meters per second. So it is not possible for you to generate speed beyond that value. And one more point to be remembered is the refractive index is always greater than 1. The least value of refractive index possible is 1. That is for air or vacuum. All the values will be greater than 1. If it has to be greater than 1, then how should the ratio be? It should always have the highest value in the numerator and lowest value in the denominator. That is why air will always be in the numerator. Because this confusion will come, I repeat it again. Remember, numerator has air and the denominator has medium. Because of which, what you can say is, refractive index is inversely proportional to the speed of the light in that medium. Are you accepting or not? Because speed of light in air is a constant. 3 into 10 power 8 is a fixed value. When it is a fixed value, can I say refractive index is inversely proportional to speed of light in a medium? Can I say that? So that is going to be the scenario. Out of rarer medium and denser medium, which one has the greater speed? Rarer. So what should happen to its refractive index? Speed is more. What should happen to the refractive index? Less. Because they are inversely proportional to each other. So that is why if you see, in some of the problems, they will give you the refractive index of two media are 1.5 and 1.3. They will not tell you which is rarer, which is denser. Because you are expected to know that. By looking at these values, can you tell me which is rarer and which is denser?
Sir?
1.3.
Sir, can
1.3
you
is.
Sir, your voice is feeble as you go away from the laptop.
Sure. Wait. It's running on hotspot. Is it better?
Now it's good, sir.
No, it was running on hotspot. Okay. Now see, refractive index is inversely proportional to speed of light in medium. So refractive index of rarer will be refractive index of rarer medium will be less than the refractive index of the denser medium, right? Then based on these two concepts, we saw, okay, now I define only absolute refractive index. What about relative refractive index? So if I have mu and I put it as 2, 1, what is the meaning of this? It is mu2 by mu1, which is equal to v1 by v2. Can I say that? mu2 by mu1 is equal to v1 by v2 because they are inversely proportional. And what do you call this value as? You call it as relative refractive index. Have this in your mind after this. After the relative refractive index, then we discussed the laws of refraction. What did the laws of refraction tell us? Incident ray, refracted ray, and normal all then what about the second point? Ratio of sin I is always a constant. And what is that constant? It's called refractive index, or you can also call it as relative refractive index, mu2 1. Sometimes you write it as mu2 1 based on this. See, this is a very, very important point, right? If I take this to be the incident ray, and if I take the angle of incidence to be I, and the refractive index of the first medium as mu1 and the refractive index of second medium as mu2, in the second medium, let me say the angle of refraction is r. Then what can I say sin I by sin r is? Sin I by sin r is as a constant. How do you write it, Ra? You write mu1 by mu2 or mu2 by mu1. Look at the diagram. So sin I by sin r will be equal to mu2 divided by mu1. That is another point you need to make a note of. Frida. But this is not how I keep writing it. This is only for the textbook version. But I've taught you an alternate way to write Snell's law. How did I teach? You first write down the refractive index. First write down the refractive index of whatever medium you want into sine of the angle made by the ray with the normal in that medium. So mu1 is present in the ray where you have incident ray. What is the angle of incidence? Sin I. Okay. Mu into sin I, sorry, mu1 into sin I will be equal to mu2 into mu2 is the refractive index of the second medium into sine of r. Correct? So this is how you do. mu1 sin I will be equal to mu2 sin r. If you want to rearrange and see that sin I by sin r will be mu2 by mu1, whichever you are comfortable, go with it. But I am comfortable with the second one because we will not make mistakes. Sorry. Shall I proceed? So after this only we started seeing the applications of refraction, in which first we saw for light passing through a rectangular glass slab. So there are two important conclusions we drew out of it. What are they? The first conclusion. There are two conclusions that we drew out of it. What was it? First one. The extended incident ray will be parallel to the emergent ray. So incident ray and emergent ray are parallel. So if they are parallel, what can you speak about their angles? Angle of incidence will be equal to angle of emergence. And third, we saw how to calculate the lateral displacement. What did the value come out as? So what is the lateral displacement? It is the distance between, perpendicular distance between incident ray and the emergent ray. So what is delta x? What? It came out as t into sin I 1 minus Root of. Remember this? So we saw the derivation for this also. I gave you the logic also, how to think. So wherever problems are based on refraction, the logic is very simple. First is, you should be sure sort of how to draw the diagram. That I can't help. I can help you with the mathematical part. So in mathematical part, what I would suggest is, since for refraction, say if you observe the laws of reflection and refraction, what is the difference you're able to find? In laws of reflection, you say angle of incidence is equal to angle of reflection. You have nothing to do with trigonometry. Whereas in refraction, trigonometry is getting involved. So recollect, trigonometry is applicable for mathematical and trigonometry. In the triangle. Right angle triangle. So for you to apply trigonometry means for you to bring in that sin A and sin R into picture, you should always look for right angle triangles. If you don't have a right angle triangle, you should consider. Okay, and in physics, the logic is very simple. When you construct it, no, you need to convert. You need to consider that trigonometric function where one unknown side will be common for both the triangles. That's the logic. If you see, yeah, without this or thickness, then we call it as thickness. You didn't do this activity, no? This is not an experiment actually. It is an activity in your syllabus. Did you do this activity? When you do this, you will understand. Prism, did you do? No, right? Prism is an experiment. When you do it right, you will actually see it laterally. Glass slab will be like this. Imagine a paperweight in a rectangular shape. A transparent paperweight rectangular shape completely. You keep it on a paper like this. Generally, what will happen? Suppose this is you would have observed this. If you have a transparent glass, for example, when you look at something directly, you will have a different perspective. If I bring this transparent glass and place it in between, you'll be able to see the image through it. But what will happen to it? It will be slightly enlarged. Why is it happening? Same logic, refraction, because you are forcing the light to pass through the two media. One will be the outer surface, and inside will be the liquid. You're able to understand. So light undergoes refraction there. Your job is to convert it into a ray diagram and solve it. How much has the light got bent is what they will ask. So one of the applications is this part. So glass slab, it will be like this. It will be in this way. It will be slightly thick. Okay. Now, when you see from this side, imagine this is one surface and this is another surface. You're looking at some object through this. Then what would have happened is, when you see it directly, you would have placed the pin at some point. It is like virtual reality only. When you come and look into this, you will feel as if it has got shifted. But actually, it is at its original position only. But light is giving us the illusion that it has got shifted. So based on that, you will keep the objects in order and then draw the ray diagrams. An activity, when you do it right, you will understand. Okay. Shall I proceed? So what is the next application that we see? Apparent. In apparent, what you see, there is a luminous object inside a denser medium, and your eye is in the rarer medium. Is this how the diagram was? The same water example. Okay. So suppose there is a glass of water. If you look at it directly, then you have a different perspective. If suppose I keep a small stone at the bottom of this, right? Now I open this, I'll see it from the top. Then what do you think will happen? You can do this with a small mug of water also. You drop a stone, it will appear as if it has got shifted up. But actually, where is it? It's in that is original position. We can't shift it because density also plays an important role. Due to density, it got settled at the bottom. Correct? But since it is getting shifted, it is appearing as if it is shifted. That is why you give a name called as apparent. Apparent is something which is actually not existing but appearing to happen to us. It's something like virtual. So that is why we found the relation between two parameters. What are they? Real depth and the apparent depth. Real depth and another. So depth is always measured from the surface. So if I call this depth as h, and if I say the refractive index of this liquid as mu, then when you see from the top, what would have happened? It will appear as if the object has got shifted slightly up. So in the ray diagram also, you can see if this is the object, you would have got image at this point. Did you get it? Yes. So it appears as if it has got shifted, and what do you call this as? Apparent depth. So what is the formula for apparent depth? It is real depth divided by refractive index. It is real depth divided by refractive index. Am I clear with this point? So what is the apparent shift that has happened? So what is the shift? H minus H divided by mu, or H into 1 minus 1 by mu. So when you're solving a problem, you need to read it carefully. They're asking apparent depth or shift depth. Okay. That's it. Okay. Since this is the last point, suppose if you reverse the scenario, this part sometimes will be asked as a problem. Suppose you reverse the scenario, means the object is in the rarer medium and your eye is in the denser medium. Then what would have happened? It appears, it will appear deeper. Correct? So if this is the rarer medium, okay, bottom part is rarer medium, but your eye is in the denser medium. And where is the object placed? It is placed in the rarer medium. Now, as a part of the exercise, can you try to complete the ray diagram? Can you draw the ray diagram? Try it. Use only two logics. What is it? Ray travels from denser to rarer. It gets shifted. Denser to rarer shifts away. Did you draw? object. Is this right? So one ray will be incident at angle angle 0. So this is O. This ray will go and hit. So when the ray travels from rarer to denser, it bends towards the normal. So what will happen? Those two rays can't meet. So you will have the image here. Is this right? So if I call this as the real depth, then in this scenario, this is going to be the apparent depth. Okay. So one point I want to make it clear. Whenever they speak about the concept of the real depth and apparent depth, the object is always kept in the denser medium only, no doubt in that. That is how your NCERT concept says. But I am interested to know now what do you think will be the relation if this scenario is reversed? Can you follow the same derivation steps that I did for the previous thing and tell me what will be the relation between them? Between apparent depth, real depth in terms of refractive index.
So in terms of
Refractive index. So in the previous one, you got apparent depth is equal to real depth divided by mu. What will you get? At least try. Label them. Find out which is angle of incidence, which is angle of refraction. Do it, no? We got it last class. Last Wednesday online. You can bring on the notes itself. Yeah. At least angle of incidence mark பண்ணி try பண்ணுங்க. What did you get? What is the answer? Anybody? We get apparent depth as mu times real depth. The logic is very simple. What did I tell you mu is? It is always a value greater than 1. If you observe, if you take the ratio of apparent depth by real depth, you will get a value greater than 1 or less than 1. In the case, apparent depth by real depth ratio. Snell's law. Mu is the refractive index of density. Right? Height is the refractive index of density medium has been done. So logic 1 into sin A will be equal to mu into sin A. Understood? Yeah. Is it clear? So in this scenario, what will happen is, if at all they twist and ask, no, you need to first check in which medium is the object kept. 99.9% they will not twist in CBS. But luck is bad, they do it. But still you should be in a position to answer. Okay. So when they generally what will happen, the object is always placed in the denser medium and your eye is always the rarer medium. So apparent depth in that scenario would be real depth divided by. So, yeah. Whereas if the scenario is reversed, apparent depth will be equal to mu times real depth. So, yeah. So having this concept in mind, if I move on to the next part, which is important again, which is called as the just give me a minute. So write down the next heading as total internal reflection. Total internal reflection. It's called TIR. Okay. See, if we have a scenario where a ray is traveling from denser to rarer medium, what keeps happening? Suppose the light ray is incident from denser to rarer. So this is the actual path. It starts moving away from the normal. If this is I, this will be R1. Now, if I keep increasing the angle of incidence, let's say from I1, I brought it to I2, what will happen to the angle of refraction? That will also increase. Because the more you keep hitting at more greater angle, it starts moving more away. So it will become R2. Suppose I have a third ray which is making an angle of incidence I3, then what will happen to the refracted ray? It will become R3. So what is the important point you are able to observe here? The more you keep increasing the angle, the refracted ray is traveling more closer towards the boundary. Is it happening or not? The more you increase angle of incidence, in which medium? In the denser medium. The more the refracted ray keeps getting shifted towards the boundary. Right? So, if I keep continuing the same process, can I see that there will be a particular angle of incidence at which the angle of refraction will be 90 degrees? Can I see it? Then this angle I is called as IC, or you can call it as critical angle. Okay. So what is basically critical angle? Critical angle is the angle of in which medium? So angle of incidence in the denser medium for which that travels along the boundary interval. There is a technical name called as grazing, GRAZANG. They'll use it in problems. They'll say the ray is grazing along the boundary, means it is passing along the boundary. Okay. Let's make it simple. The angle of incidence in the denser medium for which the angle of refraction is how much? 90 degrees in the rarer medium is called as critical angle. I repeat it. The angle of incidence in the denser medium for which the angle of refraction is 90 degrees in the rarer medium. Angle of refraction is 90 degrees in the rarer medium is called critical angle. Okay. Which one? If it makes an angle, you can't view it. You can actually you can view it from this side. Because the light is still passing along the boundary. Yeah, top you can still view depending on how much intensity is going. You can view it. So because light gets scattered also. That depends on what kind of a boundary you're using. If you're using an absorbing boundary, you can't. That is a black surface kind of thing, you can't. Whereas with the glass or something, you can. Mu, and let's say the refractive index of the rarer medium is 1. So I took the refractive index of denser medium as mu and the refractive index of rarer medium as 1. Then what can I say? Mu into sine IC will be equal to 1 into sine 90. So sine IC is equal to how much? Sine 90 divided by mu. So sine IC will be 1 by mu, or IC will be equal to sine inverse of 1 by mu. So that is the formula for critical angle, where mu is what? Refractive index of density. Right? Done? Okay. So till now I didn't explain about what is total internal reflection. So what is total internal reflection? When ray travels from denser to rarer medium, if angle of incidence is greater than the critical angle, if the angle of incidence is greater than the critical angle, ray will start bending back into the same medium. Ray will start bending back into the same medium instead of getting refracted. And this phenomenon is called as total internal reflection. Done. This is how it works. And the next point is about the application of total internal reflection, which is optical fiber. Okay, so optical fiber is a part of your textbook topic and it is theory. So that part I'm leaving it to you. You just go through it and you have any doubts, reach out to me. I'll only keep teaching you the derivation part and the other important stuffs. So I hope you're clear with total internal reflection, right? So application, what is it? Optical fiber, you have mirage, M-I-R-A-G-E, which generally happens during hot summer days. You would have actually observed it with your eyes also. When you go in a car on a highway, right? You can observe it. Okay. Apart from that, so with this concept, we are done with what happens when light is getting refracted at clean surfaces. So till now, it was a plain boundary like this, incident ray, refracted ray. Now what will happen is, if this boundary starts taking a curvature, what is going to happen? So that is why the name of the topic is refraction at spherical surfaces. Okay, so you have a boundary like this, and remember, this is neither a concave mirror or a convex mirror. It is not a mirror. It's not even a lens. Lens will have two spherical refracting surfaces. It is just a boundary which is in curve shape. Means on the left hand side also it is transparent, on the right hand side also it is transparent. Okay. Now what I'm going to do is I'm going to place an object. So it is up to me. I'll say this medium refractive index. So left hand side medium refractive index is mu1 and right hand side media's refractive index is mu2. Okay. So this, if I take it as P, then this distance is U. Is it clear? So let me call this as rarer and let me call this as denser. And one point that is to be noted here is AB has a small aperture. So AB has a small aperture. Wherever you see small aperture, what comes to your mind? Means the curvature can be approximated. Sorry. What did you say? The curvature will be approximated to a straight line. Means AB is actually like a straight line and O is a point object. Now see, yeah, radius of curvature will be more, but when you approximate it, you will consider paraxial ratio. You know what is paraxial? What is it? Rays which are closer to the principal axis, right? So if you take this to be the axis, the curvature is first of all taken to be small, and you will consider only the rays which are closer to the principal axis, right? So center of curvature for AB lies on the right hand side, except right. So if the ray, the boundary was not there, the ray would have traveled along the same path. But now it is traveling from rarer to denser. So what will happen to it? It starts bending towards the normal. So when it starts bending towards the normal, it will go and hit the surface. This is one refracted ray. This is the first refracted ray. Now what will this angle be? This angle is I and this angle is R. Is it clear? See, if I consider the other incident ray along the axis itself, then what is the angle of incidence? So what is the angle of incidence? So since it is 0, it passes through the principal axis without any deviation. So they both are going to meet at this point I. Is that point clear? So this will be the place where the final image is formed. Okay. Now if I take this to be alpha, this to be beta, and this angle to be theta, right? Now I need to find the relation between alpha, beta, and theta in terms of I and R. So first what I will do is I'll apply Snell's law. When I apply Snell's law, what do I get? Mu1 into sin I will be equal to mu2 into sin R. Let this be equation number 1. Is it clear? Now see, if I consider the triangle, if I take this point to be M, if I consider the triangle OMC, if this is alpha, this is beta, then this will be I. So what is the relation between these three? I will be equal to, let this be equation number 1. Why? Exterior angle is equal to sum of opposite interior angles. Right? Now if I take the other triangle MCI, I'm assuming everybody has drawn the diagram. So if I take MCI, this angle will be beta, this will be theta, and this will be R. So what is the relation between these three? Beta will be equal to R plus theta. So from this I can say R will be equal to beta minus theta. So let me take this as 2. I have already taken 1 minute. I'll take this as second, and I'll take this equation as third. Okay, now listen. This will be third. So from 1, what do we get? Mu1 into sin I will be equal to mu2 into sin R. Okay. Now, since aperture is small, angles are also small, which implies mu1 into I will be equal to mu2 into R. I'll call this as 4. Then what I will say is use 2 and 3 in 4, which implies mu1 into I is how much? Alpha plus beta is equal to mu2 into what is R? It is beta minus theta. So I'll get mu1 alpha plus mu2 theta is equal to mu2 minus mu1 into beta. This is what I get by rearranging. So mu1 into alpha. This side you have minus mu2 beta, that will come to the left hand side as plus mu2 beta is equal to mu2 beta, and mu1 beta will go to the other side as minus mu1 beta. Is it clear? So copy it. Done. Now see, I told you one point at the beginning. The curvature is small. So when the curvature is small, MP is almost like a perpendicular, right? So if you observe, when the angles are small, mu1 into alpha is there, right? When the angles are small, what is the approximation you can do to sine and tan? Sine alpha, so if alpha is small, sine alpha can be approximated to tan alpha, and tan alpha can further be approximated to alpha. Means sine and tan alpha will be alpha only. So here you have this alpha, right? In this place of alpha, can I replace it like this? Mu1 into tan alpha plus mu1, mu1 or mu2? Mu2 into tan theta is equal to mu2 minus mu1 into tan beta. Can I do it? So mu1 into, from the diagram, tell me what is tan alpha. Huh? MP by, okay. So this is where you need to be careful. MP is okay. U is on the left of P. So you need to apply the sign convention. Minus U plus mu2 into what is tan theta? IP எவ்வளோ? So what is this distance called as? It is called as V, and the distance from P to C is called as capital R. Is that right? Now if you see, MP divided by, how much is it? V. MP divided by V will be equal to mu2 minus mu1 into MP divided by R. Is that right? MP divided by PC in one. So MP gets cancelled. You will be left out with mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Is it clear? Okay. Done. So copy it. Tan alpha is vertical by horizontal. Is it clear? So this is all about refraction at spherical surface. Remember this formula. So it is called as refraction at spherical surfaces, and the formula says mu2 by v, refractive index of the medium in which the image is there divided by v, minus mu1 by u is equal to mu2 minus mu1 divided by r. Okay. Is it clear? So this is all for the day. So tomorrow's class I'll start with some problems based on this topic. Then we'll go to lens maker's formula. Lens formula, lens maker's formula. I'll explain it tomorrow. Okay. So that's it. Any other doubts? Okay, then we'll wind up. Those who are online, any doubt?
No, sir.
Okay.
Sir,
Yeah, so, yeah, tell me.
sir, do you have any idea when the CBC exams will be?
Absolutely. But you be ready by Jan.
Sir, can you repeat?
I'm saying you be ready by Jan.
Okay.
Okay, we'll wind up. வந்துரு சார் உள்ள அவனுக்கு தூக்கிட்டு வரப்ப ஜாகிரதையா இருக்கேன். ஒரு சைடு ஷிஃப்ட் இன்சைட். They also shift inside. ஒரு சார் உள்ள ஷிஃப்ட்